In this example, we're going to look at the ambiguous case. We're going to look at the SSA triangle and determine whether we have 0, 1, or 2 triangles. The first thing I do is set the problem up similarly every time I'm dealing with an SSA. I put the unknown side at the base, put the known angle right here, and then fill in the other 2 sides as appropriate. So in this case, the 19 is opposite the angle 43 degrees. We can go ahead and label these sides if we want. We could call this A, or label these angles, A, B, and C, which would make this little a, that would make this little c, and would make the unknown side little b. Now, in order to decide how many triangles we have, we need to know this vertical distance down from angle B to the base. If that distance is more than 19 units, then we're not going to have any triangles. So the first thing I'll do is figure out, using right triangle trig, and we can use right triangle trig here because this triangle is a trig. It is a right triangle, so we can use right triangle trig on it. So let's go ahead and calculate the height of that mysterious triangle. So we know that sine of 43 degrees will be opposite over hypotenuse. So that will be h over 26. And that tells us that h is equal to 26 times sine of 43 degrees. And if we plug that into our calculator, let's round it to the nearest tenth. That's 17.7 units high. So that tells us that 19 is long enough to reach the base. Not only is it long enough, if we notice that 19 is less than 26, then we have 2 possibilities. This 19 can come straight down to the base on the outside here, forming an outer triangle, or it could swing underneath because it's shorter than 26, so it can swing under here and form an inner triangle. So let's go ahead and draw those. The outer triangle is where we're going to start. So the outer triangle just comes straight down to the base. Bases are unknown. Let's plug in what we know. So these are the 3 pieces of information we know. We need to find angle C. Let me go ahead and put that in red, the quantities we don't know. So angle C, angle B, and side B. And let's go ahead and label this the outer triangle. And then the inner triangle, we're still going to have the 26 right there. The 19 is going to swing underneath, though, and that will be our base. This will still be 43 degrees right there. So this is the inner triangle. And our unknowns, we'll call this B star, call this C star, and this little side we'll call B star, little b star. Okay, so I'm starting with the outer triangle for a very specific reason. We are using the law of sines, and inverse sine will find an acute angle, but inverse sine will not find an obtuse angle without using reference angles. That gets a little tricky. And if we look at the outer triangle, whenever the outer triangle exists, this angle right here is acute. So that means law of sines can find it very easily. It cannot find C star directly, so we're going to find C first. But what we should notice is that C plus C star will be 180 degrees. Those are supplementary angles. So that's how we're going to move from the outer triangle to the inner triangle. And that is visible to you. That's an obvious statement. If I draw the outer triangle and the inner triangle in the same picture, so that this angle right here is angle C, this angle is angle C star. Oh, I labeled those incorrectly. Let me take that back. Well, I guess I could still leave the C. The obtuse angle is angle C star, so I want to call that angle C star. The acute angle is angle C. And this triangle in here is an isosceles triangle, so this angle there matches. So that angle is also equal to angle C. So these 2 angles add up to 180 degrees. All right, let's go ahead and do some math on the outer triangle. We are going to use the law of sines to calculate angle C. That's the only piece we can solve for. We have this opposite pair here that we can use, and then we have to use this little c side because otherwise we'd have two unknowns and that won't work. So we're going to go sine of capital C divided by 26. That has to be equal to sine of 43 divided by 19. We'll do some math here, multiply by 26 and take the inverse sine of both sides. And when you do that, we are going to end up with an angle that has a measure, if we round to the nearest unit, which we'll do, let's just keep it simple. We'll go to the nearest unit to the nearest degree. That will be 69 degrees. And that then allows us to solve for angle B. Angle B will be 180 minus 69 minus 43. And when we do that subtraction, we get 68 degrees. The last thing to solve for over here is little b. So we'll set up a ratio. I put the unknown in the top left of this proportion that we're about to set up. You don't have to, but I find it easier to put what I want to solve for in that top left. Reduces the math a little bit. And then our known ratio is the 43 degrees and the 19 that was given to us originally. So that will be written as 19 over sine of 43 degrees. And that's a pretty straightforward little proportion. Multiply both sides by sine of 68 and solve for little b. And if we round to the nearest unit, we will get 26. So now we have all three pieces of information for the outer triangle. We have these two angles and that side. Now we're going to come over to the inner triangle. The inner triangle, we are going to start by finding C star. And we know that C star is 180 degrees minus angle C. So that is going to be 111 degrees. Then we'll follow the same process that we did with the other triangle. Next we'll find B star. B star will be 180 minus 111 minus 43. And when we do all that subtraction, we're going to end up with 26 degrees for the measure of angle B star. The last thing is to find little b star. And we're going to set up a proportion very similar to what we did with the other triangle. So little b star is opposite of big B star. Big B star is 29 degrees, so, 26 degrees. And then we'll put 19 over sine 43. We can multiply both sides by sine of 26 degrees, and that will allow us to solve for little b star. And little b star, if we round to the nearest unit, will be 12 units. So we now have the three unknowns for the outer triangle. Oops, these are the three pieces of information for the inner triangle. We do have the three pieces of information for the outer triangle. So we have an ambiguous case where the result is two triangles. These are the measurements for the inner triangle. These are the measurements for the outer triangle.